Here's the extra practice for factor and solve binomials. So with binomials, we can look to see if we can factor it using difference of squares, difference of cubes, or sum of cubes. And sometimes none of these will work, and we'll just have to solve using square roots. So the examples I want to go over is number 4. So before we factor and solve, we need this equal to 0. So I'll add 125 to both sides. You get negative 27x to the third plus 125. Now, looking up top, it's always positive a minus b to the third, or positive a to the third plus b to the third. So none of the signs are really matching up. And something that you can do to make them match up is factor out a negative 1 just to make them match up. So the negatives would cancel. So I took out a negative 1. This would be positive 27x to the third minus 125 equals 0. So that's something that you could do so that it matches up. And this part here for our formula just tells us which formula we can use. So looking here, 27 is a perfect cube, x to the cube, and 125 is a perfect cube. So we want something with subtraction, and so I know I can use this formula. So that's all that part tells us, and then we use this part for the actual factoring. Okay, so to figure out a and b, I think what to the third equals 27x to the third. So you could use your calculator to take the cubed root. That's under math, and it'd be number 4 to take the cubed root. Or if you just know 3 to the third is 27. So 3x. So don't forget that x, because your exponent rule, this 3 goes to both terms. So 3 to the third gives me 27. X to the third gives me what's above. Okay, what to the third gives me 125, and that would be just 5. So my a would be equal to 3x, and b would be equal to 5. And then we plug it into the formula. So this would be a minus b equals, oh, not equals, what am I doing? A times a squared, so 3x squared. Notice how I'm writing this in parentheses, plus 3x times 5, and then plus b squared. Okay, so it might be negative 25, but we just use a positive regular 5 in here. I'm going to rewrite this and square what needs to be squared. So 3x squared, this exponent will go to both terms to become 9x squared plus 15x plus 25. Okay, so when we use this formula, this first part we could just set equal to 0 and solve. So just add 5 and divide by 3. So that's one answer. For this part, we will always have to use the quadratic formula. So a is equal to 9, b is equal to 15, and c is equal to 25. So the quadratic formula would be negative b plus or minus the square root of b squared was 15 squared to 25 minus 4 times a times c over 2a. Okay, so let's see. So we have 225 minus 4 times a times c, negative 675. So this would be x equals negative 15 square root of negative 675 over 18. And the square root of negative 675, so 15 squared is 225. So 225 is a perfect square, and 225 can divide into 675 3 times. So breaking this down would be the square root of 225 times the square root of 3, and the square root of 225 is 15. So this is x equals negative 15 plus or minus 15 root 3, and it's 15i because it was negative 675, and that's over 18. We look to see if we can reduce this fraction. So 15, 15, and 18, we can. 3 can go into each of these. This is negative 15 divided by 3 is 5, plus or minus 5 I root 3, and 3 can go into 18 6 times. So those would be our 3 answers for number 4. Let's take a look at number 3. So this one has a GCF. 4 can go into both of these. So don't let the 1 confuse you. 1 to the 3rd power is equal to 1, so 1 is a perfect cube. So we break this down. What to the 3rd gives me that? Well, x, and 1 to the 3rd gives me that. So a is equal to x, b is equal to 1, and we're using our difference of cubes formula. So this would be x minus 1, x squared, plus 1x, plus 1. Okay, so here we had to use some parentheses for when we squared it because we had a number with x. Since I don't have a number with x, it's not really necessary, and we could save us some writing here. So to solve, I just do x minus 1 equals 0, add 1 to get x equals 1. And here we have to use the quadratic formula. Notice how I'm writing what a equals and b equals. I'm not just writing a, b, c, because I notice a lot of people confuse that and think they plug x into the quadratic formula. We should only be plugging in numbers. So this is negative b plus or minus square root b squared minus 4 times a times c over 2a. So this would be negative 1 plus or minus 1 minus 4 is negative 3 over 2. And our final answer should be negative 1 plus or minus, take out that I, over 2. Okay, so our answer for number 3 is 1, and then negative 1 plus or minus I root 3 over 2. Okay, so next one we'll look at is number 8. So this will be the last one. And when I look at this, I notice it's not x to the 3rd. So GCF has been taken. There is no GCF here greater than 1. And it's not x to the 3rd. So let's take a look at our other formula here, difference of squares. When you have a perfect square minus a perfect square, we can factor it out. So similar way, you're thinking what squared equals 9x squared. So 3 squared is equal to 9, and we would also have x. What squared equals 64? Well, 8. So our a would be 3x, and our b would be 8. So this can factor out to be 3x plus 8 and 3x minus 8. And then we just have to set each equal to 0 and solve. So 3x plus 8 equals 0, 3x minus 8 equals 0. Subtract 8 and then divide by 3. And then same thing here, but add 8 and divide by 3. Okay, so you could also use square roots to solve this one. So this is how you would factor it out. But if you wanted to use square roots, I would add 64 to the other side. Okay, and before you solve with square roots, you have to divide out the number in front of the x to get x alone. And I'm going to leave this as a fraction, 64 over 9, and then take the square root. So this one, we don't really need to rationalize because they're both perfect squares. That's why I left the numbers the same, because they're perfect squares. And it'll just be x equals plus or minus square root of 64 is 8, square root of 9 is 3. So this is just another way that we can find these answers.